Advantage of having this structural foam, which is defined by equilateral pyramidal structures, each edge of which is defined by a 3-meter long cylinder with a swivel attachment at each end that has a hinge attachment on the end of that. And that's every single side of all of this structure for the basic skeletal structure. The hinges swivel and they bend. So they fit nicely when you take and build a equilateral pyramid where all the sides and all the angles are all the same and it's all triangles. You have an equilateral triangle. And it's a very, very tight mechanical structure. It hits all the different force angles that you want to hit with those flexible joints and bending moment right at the end of connection. So the automatic and the cylinder compresses. It's like a shock absorber, with the compression ratio and drop distance to be defined later, and maybe have multiple requirements depending on which kind you want to use. You could make different ones later, but first I just make one general use and make a lot of them. I just keep making them forever. The same plant, just make them. And as you attach them, which can be done quite nicely with a very simple robot, as long as you have a flat surface to drive around, you can start putting these things together, and you just attach one to the last one as you build out. And a robot can do that just fine. Just follow around the edge and just keep expanding until it hits a wall or something. And then it stops and goes back the other direction. And if that stops, then it goes up a level and reaches out a little more. And so it fits the landform. Now, as you make these struts and you cover the surface with them, some of it's going to want to go over these right-of-ways. In a place like that, if there's nothing built there and you're using the ground itself for local transportation with a roadbed, you're fine. If you're following the building code for adding infrastructure later and using that for just a local strip, you're fine. Because it all works together, because they all line up on latitude and longitude whole number lines. And maybe pre-branches on percentages or something. Whatever the locals decide, you can have everything done before any land is claimed. So you spread this stuff out and cover the surface with it. And inside you pressurize it wherever you want, or you don't pressurize it wherever you want. And use that as an overall place to do your business and not get hit by micrometeorites. And be pressurized in large spaces and have lighting all attached to the roof right above you, a couple meters up. Now, as you build that right-of-way, you'll take those struts out of the way of anything that goes through a given space, and those should line up and reattach on the exact same geometry as the rest of the foam, so it just fits in real nice. It's super easy to adjust and make that work. And when landforms get in the way, like craters and stuff, you just change your plan to fit the landform. You might build a bridge across and therefore maintain the actual legit straight train lines. You might see a mountain and go, let's just punch a hole all the way through. Just move that stuff away by robot. Just assign the robot to keep doing it until it's done and kind of forget about it. Survey as you go. Got other projects to work on. And all along the way, gabions and outdoor rail, unprotected rail, could be a foundation that's easy to put in to create rapid expansion on Mars by solving a logistical problem before people have a chance to bitch about it, like they did in the United States. Thank you. Let's see, how much? Oh, I suck. That's 5 minutes. Okay. So, how to shield the tower out of the center of Olympus Mons or off of some tall mountain would be to make it very light and to fit that overall foam scheme, but with heavier struts to raise it higher and higher, and have whole sections or floors that are as barren as possible and filled with very light gases. Make the whole thing a lift item. That would only work within the atmosphere, which, of course, on Olympus Mons you don't have. So that would be for some other place. You could use indoor pressurization and lift gases to lift loads to the top of the tower, and thereby having a radio transmission point, Barsouma synchronous orbit, essentially. If an object hits it, it's trapped within the cell pattern that it falls into. And if you make a thick cell pattern with a stiff skin on the outside of it, then what you have is a foamy, bulletproof capture engineering. You actually capture the dead satellite, the micrometeorite, the fair-sized meteorite, right? You could engineer up to the size of a car, that it would catch a car in orbit. Okay? And not injure any of the business of the day, because you make it that thick in that kind of engineered foam, and you put layers every few distances of heavy stiffening walls.